Hello and welcome. My name is Astrid Cousteau. I'm the Chief Commercial Officer at Kinéis. Thank you for joining us. Today's webinar is about all use cases you can reveal with Kinéis Space IoT connectivity. Some tips and things before starting. Please switch off your microphone and camera. If you have any audio video problems, you can try to turn off the audio for a few seconds and then turn it back on again. Or if you have any other problems, please refresh the page. In order to get everybody connected, I'm leaving you for a few minutes with a movie, and I will be back with you straight away.
This proven system will provide connectivity for a whole host of activities: extreme sports, agriculture, small-scale fishing, safety. By 2030, over 70 billion devices will be connected. Imagine.
So I think we have a technical issue. Okay, starting the film again. Sorry about that. So for those who joined us during the video, I'm Astrid Cousteau. I'm the Chief Commercial Officer at Kinéis, and thank you for joining us today. Some tips and things before starting. If you have any audio video problems, you can switch off the sound and turn it on back again to check if the sound is better, or refresh the page. Please switch off your microphone and camera. And during the presentation, you have our chat available. On our side, we have our field application engineer available to reply directly to your different questions. So if you have any questions, don't hesitate to drop your questions during my presentation. So today's webinar is about all use cases you can reveal with the Kinéis Space IoT connectivity. I'm with Laurent Gineste from Exotic, who is one of our device manufacturers and a global smart system solution provider. So let's start with what Kinéis, for those of you who are discovering Kinéis for the first time, and for those that need a small reminder. So first of all, what's Kinéis? So Kinéis comes from CLS and the CNES. CNES, who is the French space agency, and we come from this, let's say, historical space IoT connectivity already, because CLS and the CNES are connecting boys and animals already since the early 80s for scientific and environmental applications. So Kinéis, we are global satellite operator. Today we have already 8 operational satellites in orbit, so we are fully operational. In 2023, we will launch 25 nanosatellite constellation. So these nanosatellites are fully validated today, technically speaking. We will have 20 ground stations worldwide to collect the data from the satellites as quick as possible and to have an average revisit time of less than 15 minutes. And we have a global coverage maintained. So our service center is supplying services 7 days a week, 24 hours a day. So we are a global connectivity supplier, and our connectivity strategy is global coverage. So wherever on the globe you are, we can collect the data. We are in an IoT application, so which means low data rating. We have a low power consumption, and we are easy and reliable, which means that there is an easy integration of Kinéis connectivity inside different devices, and we have a robust and technical solid solution. So a little overview of where we are standing today. So this project is around very strong space industrial players. It's a new space project because there is more private investment than public investment. So you can see at the left side, we have, let's say, this technical guarantee because the project is based around very strong space industry players like the CNES, who is the French space agency, Thales Alenia Space, Sirlinks, and Emeria. At the right side, you see that Kinéis project is fully funded, and you have our different shareholders like CNS, which is the major shareholder, and the CNES, and then you also have the French public banking, and some at your left hand, some of the industrial space suppliers, and also IFREMER, which is the Oceanography Institute in France. Today we have already several device manufacturers that are embedding Kinéis connectivity. So you have some of them mentioned on your left hand, which is Exotic Systems, Next4, Aribada, Sirlinks, Altior, and Advanced Tracking. And today, as I told you, there is an easy integration and hybridization with terrestrial network operators. So we already onboarded some of them, like Bouygues Telecom, Opgenius, and Sierra Wireless. So what can you do with us today? So we supply really truly IoT everywhere on the globe. So we have no blind areas worldwide. So you can collect data from our system and at any location you are, even if there is absolutely no network available. We can track and locate objects. So we have a native positioning technology based on Doppler technology, which gives you 150 meters accuracy. If this is not enough, of course, you can also use other GNSS chipsets like GPS or Galileo, but this is using more power. So it's up to you to decide what is adaptable for your use case. We can collect data, so it's small data from 30 bytes messages, and our technology is compatible with all existing sensors. And then also we have alerting system, so it will send only the information if there is an alert on the device or on the situation. And we have also two-way communication, so uplink and downlink available. So the average revisit time in 2023 will be less than 15 minutes. Our technology supplies no roaming issues. That means, like terrestrial networks, you can have problem integrity agreements between different telecom operators. And it's low transmission power, which gives you maximum autonomy of the device. And we also have miniaturized devices, so we have devices of only a few grams and a few centimeters. So the system today is fully bidirectional. So you have a system diagram here. So Kinéis is applying a direct-to-satellite technology. which means that the object will communicate directly to the satellite. The satellite will send back the information to the ground station. The ground station will communicate with our server center and push the data to our different customers. All this is, of course, fully bi-directional. So some of our product updates today. So our product line is in different, we supply different solutions today. So first of all, we have our chipset, which is basically an RF transceiver on which you need to implement more intelligence. We have a module on which is a plug and play solution, which is embedding the different intelligence and the different communication systems. It's easy to integrate into any device, so it's our plug and play solution. Then we have different solutions to test our connectivity straight away. So we have what we call interface boards. These interface boards are open standard boards like Arduino, Mango H, and STM, on which you can plug directly our module and test the connectivity. And then our last product is a demonstrator. For those of you who would like to test Kinéis straight away, we have an on-the-shelf solution with a device that is implementing, let's say, the most used sensors today, like temperature, pressure, shock, humidity, and all other major IoT sensors that are available. So today, in the end of 2019, we have launched with the launch of the first nano-satellite Angels. We just validated the first service, which is operational since mid-October of this year, and is, let's say, carrying the first Argos Neo miniaturized payloads. So this very new VLD A4 modulation is now available for satellite IoT, and all devices are already connected with Kinéis connectivity. So some key points of this Angels new satellite. So we are able to supply small data packets, 7 bytes, transmitted at very low data rate. The transmission power is considerably reduced to 100 milliwatts for a better autonomy and reduced component costs. And this modulation is already available on Kinéis chipset. So technically speaking, we also, let's say, the communication through the satellite is really linked to our the performance of the antenna. So we have several engineers at Kinéis working at antenna reference design. So we also, let's say, discuss with our different partners and give them advice which antenna to use to have the best performance to communicate with our satellites. Of course, there are also, let's say, new technical possibilities here. So if you can compare this to, I think the first mobile phones where you had, let's say, a big phone with an external antenna, we are now working on, let's say, compact versions, flat versions with embedded antennas. So at Kinéis, we are doing the same thing. So we still have, let's say, the external antenna, but for those of you who would like to work on more compact versions, we are working on new releases of referenced antennas, which you can see at the top, at the bottom, at the left side, with, let's say, new technologies to embed the antenna inside the device, and still having a good quality of communication with the satellite. So our applications today, so these are the different markets we're targeting at Kinéis. So we have our base, business cases that are fully addressed by CLS today, which are the applications linked to the science and environmental applications. So it's tracking animals and boils for institutional and government programs. Also maritime solutions, smart agricultural solutions. So in the smart agriculture, it's like livestock monitoring and also crop management and everything that's linked to water management, which can be the quality of the water or the water level in agricultural projects. The outdoor activities you've just seen in introduction, our film about Kinéis adventure. So it's let's say it's an alerting system and monitoring system for alerting on let's say extreme sports situation where no connectivity is available. And in outdoor activities, we also supply let's say support for emergency situation for remote workforce monitoring. Aid and development is everything that's linked to humanitarian projects. And then we have two very big new sectors, which is transport and logistics, which would be container tracking and asset tracking between industrial plants. And network and infrastructure is everything that linked to utility networks for smart projects and smart monitoring projects of energy projects like electricity, water, and gas, and also into the oil and mining industry. So I will highlight just two of them before switching to the second part of our webinar with Laurent Gineste, who will highlight some new applications. So I will just give you an overview of two of the market segments that are fully addressed today by CLES, and they are, let's say, the historical IoT space connectivity since the early 80s. So it's linked to everything that is scientific and environmental projects. It's to study and better understand everything that's linked to the protection of our planet. They are, let's say, working on projects for more international and institutional scientific programs. And you have the different market segments just mentioned over here. They are, let's say, the base business line of Kinéis today. In the maritime sector, Kinéis is giving a great new opportunity for the monitoring of small-scale fishing, since we have this, let's say, more economic way to address our different markets. So it's also on fishing and EEZ survey programs. It gives you also the opportunity, let's say, to address leisure boat monitoring for more tourism and private markets. And it's easy to use hybrid solutions. So we can combine easily this technology with mobile and satellite solutions. So we can hybrid with other technologies like cellular technologies like G2, or also terrestrial network combinations with LoRa or NB-IoT. And this is also supplying end-to-end solutions. So I will leave you now with Iiot System, who is our device manufacturer and already integrating Kinéis connectivity today. So Laurent, thank you for joining us, and good luck with your presentation.
Thank you, Astrid. Thank you, Kinéis, to inviting me and Iiot Systems to this cool webinar to talk about Iiot Systems, to talk about what we are doing and what we are doing now with Kinéis and how we are doing it. In this presentation, I will present 4 use cases for applications we are dealing with right now in Iiot. Use cases we can do now with a solution of Kinéis that we cannot do before. So just to introduce myself, I'm Laurent Gineste. I'm Iiot Systems CTO and co-founder. I frequently say that I'm born with a soldering iron, but it's not really true because I began when I was 8 years old and not really when I was 0. Anyway, what we are doing and who we are in Iiot Systems. As I mentioned just before, I co-founded Iiot Systems in 2007 with 2 of my friends, We were all three in labs in Clermont-Ferrand, France, and we were passionate of technology. 13 years after, we are now a team of 15 engineers, hardware engineers, firmware engineers, software engineers, data scientists, mechanicals, with true passion with new technologies. For 2007 to now, we developed many solutions around Internet of Things. We often say that we grown connected. But the main problem we are trying to solve right now is to build useful and reliable systems to change our daily life, and we expect to change the world with these kinds of solutions. Today, there are 6 investors in Exotics, the 3 co-founders, 2 well-known industrials, Michelin, the world's first tire manufacturer, Limagrin, world's number 4 seed company, and 1 venture capital society, Sophie McMartins, and obviously a new space IoT and low power global array network. We choose Kinéis. One thing very important for us, our real DNA, is the agility in everything we do. We are working in sprints, 15-day sprints, 2 weeks, and we are often able to deliver new systems with simple electronics prototypes in 1 or 2 sprints. I show you at the end of the presentation an example of a product based on Kinéis, as shown a few minutes ago, Astrid, a module from Kinéis that we did just in a 1 sprint. Our team are obviously based on people with different skills and multidisciplinary teams, skills like hardware, firmware, and so on. Our main goal is to deliver projects to our customers very quickly with short lead times. We have many projects that are delivered in less than 2 or 3 months in Exotic Systems. For this, we have one main offer on the left of the slide, which is a design house offer of our different skills. For example, you can ask us to develop just a board, just an electronic board, or a complete system with plastic and so on. We are fabless. We have no fabrication inside our company, but we can produce and certify your products with our partners in France, EMS, certification labs, plastic molding or injections. We have also 2 other offers on the right side of the slide, which can help industrial companies to integrate IoT, industrial IoT, IIoT, in their process or in their factories quickly. The first one is Iiot Explorer, which is based on design thinking process, and a suitcase that you show on the slide that you can, with a bundle of different objects inside it, that can collect and transmit information very easily, information such as temperature, vibration, movement, and so on. And the last offer on the bottom right side of the slide is products themselves. We sell this kind of products. Today we have 6 different products, and some are in the end of certification process. This slide just to illustrate the places and systems we are working on in Exotic Systems. So you can see earth movers on the upper left of the slide for Michelin tires, in mining, agro equipments, in smart agriculture, or with robots or process lines in the bottom right, inside factories. Just to focus on some specific skills of Exotics. The first one is to design rugged and ergonomic systems. You can see some example of this kind of products we have developed for Michelin in automotive and mining business lines, called on the left side Michelin Track Connect, and on the right side WAND. And in these kinds of products, we receive messages, radio frequency messages from connected tires through electronic inside the tires. These systems are called TPMS, for tire pressure monitoring systems. This TPMS works on 433 megahertz frequency band. This is just right in the middle of the two bands of Kinéis, or the two bands of uplink and downlink, 41 megahertz for uplink and 66 megahertz for downlink. So we had the chance to reuse a lot of work we have done in 4033 megahertz because it's really close to Kinéis bands. For example, right now, trying a low noise amplifier, LNA, used in TPMS receiver, we developed to increase the sensitivity in downlink messages from satellites, from Kinéis satellites. Now, a slide to expose one of the main problem in our daily job. You already know that the globe is covered by less than 15% of territorial networks. Especially in IoT networks, there are many blind spots everywhere. I show you two examples with LoRa by Orange and Sigfox. This is maps that I collected from internet. These maps are close to Clermont-Ferrand in France, where we work in smart agriculture. You can see how many blind spots there are in a few square kilometers. Obviously, if you want to use this kind of networks in India, Tunisia, or China, you will wait a lot of time and short the business time. Okay, so to solve these problems of blind spot, I was looking in exotic systems above my head, above our head for a long time, thinking of satellite or hybrid telecommunication. But Iridium was the only one we were looking at, and was a way too expensive. Hardware and telecommunication was way too expensive. Luckily, we discovered Kinéis with an already operational systems that share our values and our taste of innovation, as Astrid said before, good taste for innovation. So we think that Kinéis is a true player, a real player in the new space area, especially because of their experience, 40 years experience in Argo system, and their public-private funding raising 100 million just before COVID pandemic. So we really think that Kinéis is our best partner for this kind of use cases. Now it's time for me to go further in details of these use cases we could not address before Kinéis LPGN system, low power global area network systems. I will first talk about industrial use case, two use cases. The first one is about the monitoring of small photovoltaic station in developing areas, in developing countries. And the second one is to monitor sensors in backcountry or offshore areas. So the first use case concerns a startup providing a solution for intermediation in NGOs solar deployment called SolidarLink. It's kind of Uber for NGOs in solar station. They need an object, simple and low cost. This is very important. The cost is very important to survey photovoltaic station. Else, if it's not operational, the system triggers an alert and call for repair. The technical features are very simple. The system simply measures voltage of the station and current through the batteries, and then send every 15 minutes or more the average current and average voltage, and so the power of the station, and transmit also some status. So we only need up to 6 bytes to uplink 6 bytes every 15 minutes. It can be 24 bytes every hour. It's also possible. So there is no problem for payload and duty cycle with this kind of solution with Kinéis, obviously. The system is powered with the station itself, so there is no really problem of power inside this use case for transmission. The best part, of course, is the global coverage allowed through Kinéis global connectivity, so the station could be virtually anywhere around the world. The second industrial use case is about an industrial manufacturer of sensors, industrial sensors that you can see on the right side of the slide, used in plants or pipelines that can be everywhere, even in offshore factories. Therefore, we need a system that could be plugged with this kind of industrial sensor through their communication system, generally Modbus or HART protocol through RS 485 buses. To get some values in specific registers and send these values onto a cloud platform, and eventually to trigger an alarm if a threshold is exceeded, for example, pressure exceeded. These systems need only 1 or 2 uplinks by day if everything is okay. And this kind of sensor are often already powered, so there is no power problematic in this kind of use case, thus making another time Kinéis the good choice for this application because there is a global connectivity. So tracking use cases, Astrid showed some cases a few minutes ago. Let's talk about tracking use cases. The first one is about container tracking for supply chain. And the second one is about seed bins tracking for smart agriculture. So the first concern a young company called SafeCube that is born from a partnership between Argon Consulting, Sigfox and Michelin, to help this tire manufacturer to regain control and accelerate their intercontinental supply chain. They need a global tracker, eventually an hybrid one based on Sigfox, because of course SafeCube is a joint venture with Sigfox. But a second link, an hybridation could be a good choice. This second link could help where in areas where there is no coverage of Sigfox. This use case does not need a fine localization. They just want to know the areas where the container is. So there is no need of a GNSS, a GPS system to locate the asset. Doppler localization provided by Kinéis is enough in this kind of use case. One position a day is enough in this use case because the containers are not moved every time. But the power consumption must be optimized to allow a long-term battery life, months or years. The last use case I will talk about is one I know well because it is a use case we address at Iiot Systems. We want to help farmers during harvesting seasons. In these times, there are many bins traveling around the field to transport the seeds from the field to storage areas. These bins are dropped by trucks or tractors everywhere in the field, and it is sometimes very difficult to manage the workflow of these assets. So we developed at Iiot Systems a solution based on the trackers that we developed to localize this bin in the field based on Sigfox. But we realized that I said a few minutes ago that blind spots are everywhere around us in the field in rural areas. So after exposing these use cases, you will easily understand why we are developing these systems that you can see in the slide. This is our new Kinéis-based LPGAN rugged systems based on our box, which is IP69, so it can resist from dust and water, and EK10, so it's really strong, very rugged. And inside this box, we have developed a new board, and so the first samples of the MVP that we call the MVP for minimum viable product 0 will be already there in a few days, and it's based with the KIM1 module, and we will finalize the MVP1, which is this time based on the chipset, on the last chipset of Kinéis, the Arctic Air3, and we are finding the disponibility of the system will be, I think, in February or maybe in March 2021. Just a few words about antennas, because Astrid showed that Kinéis is working on antennas, on embedded antennas. We are also doing some stuff inside Exotic. We have a PhD student that is working on this kind of technology, and I show you the next publishing scientific article that is going to be published in few days, based on small antennas, dual band antennas to transmit data in 400 megahertz and 80 or 900 megahertz. So you can use this antenna for Kinéis systems and LoRa or Sigfox antenna. So I think I'm done for my presentation. So if you have any question, I think Astrid will and I will respond to your questions right now.
Okay, thank you very much, Laurent, for your presentation, and let's say also about these real use cases you are addressing today, and also about the integration of Kinéis connectivity you have ongoing at Exotic Systems. I hope to all of you that, let's say, the different explanations and the real business cases Laurent gives you, let's say, some new insight of space IoT connectivity. Let's take now the different questions, so we can dispatch the different questions between Laurent and Clément. Clément, our field application engineer that's online with us today. I think some of them have already replied. There are some questions, Laurent, about SafeCube, how they are integrating the connectivity inside their container solutions. Is that something you would like to reply on?
If the question is there any tracker inside a container, I can't respond for them, because I don't really know how they plug the tracker inside the container, but I know that they already done some tests, and even I think Clément, your Kinéis Clément has already done some tests to estimate that we can transmit with Kinéis inside a container, and the result that I know right now, it shows some result. It can work, but I can give some technical information on how the attenuation is inside the container. Obviously, it's a strong attenuation because the container is made from metal. But I think we can imagine a container with a tracker inside easily if we have some time and some time to develop this kind of system with SafeCube or with just Exotic Systems.
Okay, Clément is not. I think Clément is replying directly to some of your questions. Let me see. Sorry. Okay. Well, I think it's a specific use case. So we did some testing. So it's something we can get back onto you after the session. We have also other companies working on container tracking. So I would like to keep this question with us and perhaps follow up after the session. I've seen a question coming up higher on that. Yes, we know. So I think Clément's just writing on the chat only, let's say, the low power connectivity at the devices and can last for several years on battery power. So that's already replied to somebody that dropped Gilles, who dropped the question about Kinéis connectivity low power. Can Kinéis battery based service work on batteries for years? Yes, of course, because we have this low power transmission. Then, of course, it depends on the number of messages you would like to send per day, because potentially when you're sending several messages, it's using the battery capacity, and also it's linked with the number of sensors that are embedded inside the device. The two-way communication, is there any idea on the capacity to send messages? Perhaps it is more difficult to accommodate many downlink packets? That's a question from John. It's low power messages. So we're on 32 bytes. So it's really linked to IoT applications. Also for the downlink. He's there. So just filling up. Thank you, Clement, for joining. So I went through the different questions. I think the first question we were following up was about SafeCube, and it was about a question from Gael, how it worked for containers below others, problem with a lot of metal between the checkers and the sky. Do you have any feedback about that? So I think we have several use cases for container tracking. So I will let you jump in on that one.
Yeah, I answered with the chat already. We have tested, as Laurent said earlier, the communication inside a container, which was successful, but with very weak performances, very few messages received, of course, because the container acts as a Faraday cage. So it's quite hard to have the signal out of this container. So it was a higher power and few messages. We have not tested with other containers on top of this container, so we cannot provide an answer on that. However, for other questions such as the transmitting power, today we work at about half a watt, 500 milliwatts. In the future, with the new satellites in 2023, we should be able to transmit at lower power, about 100 milliwatts. So it will really improve the autonomy of the devices. Then other questions.
John, about Sigfox announced their own LEO LP gen in 2019. Is this proceeding? I don't know. There's not a lot of communication about this project. It's a project linked with Eutelsat, and let's say there's absolutely no communication anymore around that, so I'm not able to reply on that.
Yeah, I suggest we focus on questions actually aimed for Kinéis, such as which module maker is developing LoRa and Kinéis module. We have a few, such as Sticker in a module manufacturer in. I mean, it's not a module; it's a device that integrates both our module and the LoRa module. It's in the Paris region. About relay modules in the form of mesh networks. We have considered it. We have not worked on it ourselves, but I think a few companies are working on this subject. And just to answer the last question from Sergey, we do have acknowledgement available with the downlink. So yeah, that is available if needed.
Okay, so
we have covered all the questions, but if you have additional questions, don't hesitate to contact us. There is the email address on the screen.
Yeah, just the question of Sergey. Yes. Could you send this article? I think the article of the antenna, embedded antenna. So I can send the link for everyone who wants this article. So don't hesitate to contact through mail, as just said Clement.
A few last questions. Can you repeat the downlink latency time? how many ground stations will there be? We are deploying 20 ground stations, but that will be located homogeneously on the globe, so the latency is optimal. Today, the downlink latency time is a bit higher than the uplink latency time because not all satellites have the downlink, but in the future constellation of the 25 nano satellites, all the satellites will have the downlink, so the downlink latency time will be the same as the uplink, which is about 15 minutes in the worst case, which is at the equator. And then a question on LoRa solutions. Today, as I said, we have a few manufacturers working on hybrid devices with LoRa and Kinéis, and they are not deploying at a scale yet, but will be very soon.
So if there are no further questions, I think it's time for us to let you go, and do not hesitate to send us your feedback about this webinar on the questionnaire that will be following. And if you have any, let's say, business cases or any further questions, you can always get in touch with us. So from now, I would like to say goodbye to all of you, and looking forward to see you soon.
Okay, thank you.
Thank you everyone for watching.
Bye-bye.